For fx equals x minus 2 squared times quantity x plus 1 cubed times quantity 2x minus 5, answer the following. Find the zeros of the polynomial and state multiplicity of each zero. State whether the graph crosses or touches but does not cross. So there are two options: crosses or touches but does not cross the x-axis at each x-intercept. Okay, and then we find more. Let's answer part A and B. We have three factors, and x minus 2 becomes 0 when the x equals 2. So 2 is a root of this polynomial, and square means multiplicity 2, it comes twice, 2. And when the multiplicity is 2, the graph just touches but does not cross the x-axis. The graph touches the x-axis but does not cross. Okay, next, x plus 1 cubed. We know that x plus 1 becomes 0 when x equals -1. So -1 is a root or 0. Okay, and we have cubed. Cubed means it comes 3 times: -1, -1, -1, multiplicity 3. And when the multiplicity is 3, the graph crosses the x-axis. So we'll have the graph crosses the x-axis, like here the x, and graph just goes through the x-axis. And the third, 2x minus 5. So we need to find the x value for which 2x minus 5 becomes 0. So let's try over here. 2x minus 5 equals 0 when move 5, solve for x, move 5 over. So 2x equals 5, divide by 2, 5 halves. So the root or the 0 is 5 halves. Okay, and the power is, there is nothing, means 1. So the multiplicity is 1. So it's like 3. So odd multiplicity, that means the graph crosses the x-axis. Okay, next, part C, find the intervals over which the graph of EF is above or below the x-axis. So we can sketch a rough graph, not rough sketch of this function. We know the degree of this polynomial is 2 plus 3, 5, 1, 6, or we can check from here, 2, 3, 5, 6, degree 6. So even degree, and we have leading coefficient positive because there is a positive 1x, 2x. When we multiply out everything, it will be 6th power. Okay, 6th power and positive leading coefficient. So the graph will be like the following. Okay, x-axis, y-axis, it rises eventually on the left and it rises on the right, because we have positive and 6, 2, 3, 5, 1, 6, and positive. So this will be the case. And now we have 3 roots: 2, -1, 5 halves, 0, 1, 2 is here, -1 is here, and 5 halves, that's 2.5. so right of 2 somewhere, let's say this is 5 halves, and this is the case, eventually rises on the left, rises on the right. So at -1 it just crosses, so the graph just comes and crosses. Then at 2, touches but does not cross, so it's from below, it just touches but does not cross, so comes down. At 5 halves it crosses, and it goes above like this. Okay, so the graph of this polynomial is above the x-axis, where -infinity through -1, and 5 halves all the way, 5 halves all the way to infinity. So the graph is above the x-axis on negative infinity through negative 1 and 5/2 through all the way, and the graph is below the x-axis from negative 1 to 2, 2 to 5/2, or all the way negative 1 through 5/2. The graph is below the x-axis on negative 1 through 5/2. Okay, this C is done. And determine the y-intercept. To determine the y-intercept, all we have to do is plug in x equals 0. So when we plug in x equals 0, so this is negative 0 minus 2, negative 2 is squared, 4, 0 plus 1, 1 cubed 1, 0 minus 5, just minus 5. So 4 times 1, 4, times negative 5, negative 20. So negative 20 is the y-intercept. So let me write over here, y-intercept is negative 20. We plugged in x equals 0 into the function. Okay, now what is the maximum number of turning points? So let me answer here, maximum number of turning points. So look at this graph, it's kind of clear. It's coming down here, 1, 2, 3. So we have 3 turning points, but we could have more than that. Though we have only 3, look at the degree. What is the degree of this polynomial? 2 plus 3 plus 1, 6. The degree is 6, so this graph could have 6 minus 1, 5 turning points. So the maximum possible is 5. Though it has only 3, the maximum possible was 5. For any 6th degree polynomial, it can have at most 5 turning points. Final.